Hi, I'll be going over the umpire process for a number of 1 bits. So given a positive integer n, write a function that returns the number of set bits in its binary representation, also known as the Hamming weight. Put n equals 11, then output equals 3, so going over the first example. Input binary string 1011 has a total of 3 set bits. Example 2, input n equals 128, output equals 1, and this is because the input binary string 10000000 has a total of 1 set bit. Then for example 3, input n equals 2147483645, and the output is 30. Then the input binary string has a total of 30 set bits. Okay, so yeah, we're just looking for the number of ones in binary of this number, basically. So the way we can do that is probably the easiest if we use the mod operator that gives us the remainder, or gives us the rightmost bit. And then from there, we just want to shorten our, just want to look at like the next number in the binary number, right? So say like we're first looking at 1, then we just want to look at the next number and check if it's a 1. So pretty straightforward solution. Let's see. Okay, so we just want the remainder. So first we need a result variable, so that's what we're going to return, right? So we want the number of ones, so result equals 0. And then, so we just do while n, right? So we just keep going until the number here, all the way the leftmost bit is in 0. Then we just can add it to res, so because if it's a 1, I'll add to res. If it's a 0, it won't add, right? So we just do res plus equals n%2. And then from there, we can just do, shift n, right? So we shift n to the left. So n, sure, I forgot what the other is called, but I think you can do it that way in Python. Okay, and then from here we can just return res, and this should be correct. So I'll go ahead and run it. Nice, so we got all the first test cases, and I'll go ahead and submit. Nice, so yeah, it looks like it works. Yeah, so because like we know we won't have a number greater than 32 bits, our time complexity is like O of 32 or O of 1, so we have constant time complexity. And then the space, because we don't use any extra data structures, that also ends up being O of 1. Then thank you, that's my umpire process for a number of 1 bits.